Good morning, friends. We are learning our subject that is data visualization. The subject code is 3160717. And in that, we are learning our module 1 that is Introduction to Data Visualization. Right? Let's see the last lecture revision. That is, we can say we have seen the definition of the visualization. So what is that? Let's see. Visualization transforms data into images that effectively and accurately represent information about the data. So now we want to know about the visualization pipeline. What are the steps of this pipeline? They are data acquisition, then data enhancement, visual mapping, and rendering, right? There we have considered the visualization process in detail also, that is acquire, parse, filter, represent, refine, interact. And the first step is acquiring and visualizing the data. So for that we have considered file on disk, stream from the network, digitize, signal. This can be the data sources for us. And what are the stages of acquiring? For that we have considered that whichever techniques are used, they can be the modulation, sampling, we can say digitization, coding, and file formats. Right? Okay. So now we want to start with today's topics, and that is, we can say, simultaneous acquisition and visualization. If, say, data is continuously changing, and we need to get the data and visualize it, it will make our life a bit difficult in the way that continuously, that means we can say that in some time interval, maybe say few seconds or few minutes, we have to get the data, and then after we have to do the visualization of it, right? So for example, we can say that on FB or Twitter or anything like that, wherein continuously the data is uploaded, right? Continuously the data is being uploaded. From that we have to get, and we should make the visualization, right? So simultaneously we have to download and give the visualization. So for data enhancement, what do we consider? It decides important aspects or features. We must somehow turn our raw data set into more appropriate representations, that is, we can say, enrich data sets. Data filtering or data enriching, two tasks. So what are there in it? Extract relevant information. As for example, extracting name, address for less attendance data of students, right? Do we need to have the marks of each semester for that student in that? No, it is not required, right? So what do we say is extract relevant information and ignore irrelevant information for a particular task, right? Next is enrich with high level information that supports a given task. So, what do we consider? High level information we should have. We should not have only the low level information, but we should have the high level information, or you can say that we will remove the noise also, and we can say we will be having the better information, right? So for that, the example is medical data. Noise data removal, that is enhancement of certain material data, right? The input is raw data set, whereas output is enhanced data set. So next is in the pipeline of data visualization, we consider visualization mapping. So what is that? Mapping. The word itself says that we have the mapping function, isn't it? That is, some data is there that will be mapped to some other data, right? So what do we say about that? Once we have the needed data, that is by removing the noise, by enriching it, by considering only the relevant task, we have the needed data. Now what should we do with that data? We must map it to the visual domain. So, what do we do for that? Mapping function. Map data of D to DV, that is the visualization data. D is the data set and DV is the data set of visual features. Next step of pipeline of data visualization is rendering, right? So for that, first of all, let us have the comparison about mapping and rendering. What do we say? Mapping, that means what? Convert invisible to visible representations. And rendering means simulates the physical process of lighting a visible 2D or 3D scene. The visual domain is a multidimensional space whose axis or dimensions are those elements we perceive as quasi-independent visual attributes such as shape, position, size, color, texture, illumination and motion. That means animated 2D or 3D shape. Next, what we want to know is rendering. That is ND to 2D, n-dimensional data to two-dimensional image, right? Okay. So what is there here? That is data are transformed to image data. The rendering operation is the final step of the visualization process. It takes the 3D scene created by the mapping operation together with several user specified viewing parameters such as the viewpoint and lighting and renders it to produce the desired images. In typical visualization applications, viewing parameters are considered part of the rendering operation. This allows users to interactively navigate and examine the rendered result of a given visualization. Indeed, if the viewpoint changes but the 3D scene produced by the mapping stays the same, all we have to do is render the scene anew with the new viewing parameters, which is a relatively cheap operation. So, here anew, right? So, next is what we want to know is type of data visualization. So, what do we consider in that? Three types of data visualization we want to consider. One is scientific visualization, second is information visualization, and third is visual analytics. So, what they contain, let's see about them. For scientific visualization, specifically concerned with data that has a well defined representation in 2D or 3D space, as for example, from simulation mesh or scanner. It is having the structural data. It is having, say, medical data, right? Second is information visualization. What is that? No inherent structure. For scientific visualization, we can say structural data is there. For information visualization, we can say no inherent structure is there. Like news, stock market, top grossing movies, Facebook connections. Fine. The third type of visualization is visual analytics. What is that? Use visualization to understand and synthesize large amounts of multimodal data. That means audio, video, text, images, networks of people, right? So, three types of data visualization is there. One is scientific visualization, second is information visualization, and third is visual analytics. So, what sort of scientific visualization we can see? Specifically concerned with the data that has well defined representation in 2D or 3D space, right? That means from simulation mesh or scanner. So we can see in the image this type of visualization is there, and what is it called? That is scientific visualization. Information visualization. What do we say about that? It is concerned with the data that does not have well defined representation in 2D or 3D space. That is, we can say abstract data is there. So we can see the information visualization images here in the picture. The third type is visual analytics. So, what do we say about that? Integration of interactive visualization with analysis techniques to answer a growing range of questions in science, business, and analysis. Making sense of multimodal data, that is audio clips, video, photographs, and transcripts. So, what sort of images or what sort of visualization we are getting? They are seen in the pictures available here. Next is what we want to know is modes of visualization. So, what are the modes of visualization? They are interactive visualization, interactive storytelling, and the third one is presentation visualization. So, what are the differences of these three modes of visualization? Let's see them feature wise comparison. So, according to user interaction, what do we say? Interactive visualization, for that, user controls everything, including data set. Interactive storytelling, for that, what do we say is user can filter or inspect details of preset data set. The third one is presentation visualization, wherein user only observes. With the graphics rendering feature, what do we say about interactive visualization? That is real-time rendering. Same is the case for interactive storytelling. So what about the presentation visualization? That is pre-computed rendering. What about the target? That is individual or collaborators for interactive visualization. For storytelling, we can say mass audience. And for presentation visualization, the target is colleagues or mass audience. For medium, what do we say? For interactive visualization, it is software or internet. For interactive storytelling, the medium is internet or kiosk. For presentation visualization, the medium is slideshows or videos. So, what are the applications of the data visualization? We can list out a few here, but otherwise, many more can be there. So, we can say retail banking, government, insurance, healthcare and medicine, telecommunications, transportation, capital markets, asset management. See, retail banking is there where we want to see the visualization. Why? Because we want to see, say, outlier, that is the data which is not following the normal behavior of other data. From that, we can detect the fraud. From government, also we can say we can consider the data where we group people, that these people are interested in this type of government activities and this type of people are interested in other type of government activities, right? So the third one is insurance. There also we can consider the fraud detection. For healthcare and medicine, we can say that we need to have the visualization, that is will monitor the health of, say, people of our India, and will see that in this particular area many people are affected by, say, for example, corona, then the supply of the medicine or vaccine related to that should be available in more quantity in that particular area. Fine. So through the visualization, we can see that very easily that in a particular area we are having more problems, and healthcare or medicines are much more required in that particular area, right? If you see the Excel file, or you can say data, that will make our life too complex, isn't it? For telecommunications, for fraud detection, or whether the phone is hacked or not, or if we can say that different types of people are grouped, then we can say that those will be given different schemes of, say, telecommunications. For example, let me say that few people are having the habit of talking too much on phone. So for them we can give the schemes where more calling is available. Few people are having the habit, they talk much, but through, say, SMS or WhatsApp, they do not talk, right? So for them, we can provide much internet data, that is the mobile data. Fine. So different categories of people are there, and they are being grouped together through clustering, that is the machine learning algorithm. And 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 what do? Is we visualize it. From that we can understand very easily. Fine. For transportation also we can have the proper data visualization. From that, from this particular area many people are going, but from this other area less people are there. Okay, so put more buses or more transportation in the area where people are more using the transportation. Fine. So that can be taken care of, and no need to look at the big Excel files or the data, but through visualization it is easily interpreted and we can work with that. Capital markets, asset management, there also we can say that whatever are the graphs, from that we can understand where to invest the capital, where to invest more these days. Building, and we can say such market is down, so share market, it is okay, not so good, so where to invest, right? So all these things we can see through the visualization, and based on that we can take the decision. Fine. Online data visualization websites. So, what are they? This I got from the Coursera course on data visualization. So, you people can also register for the same, enroll for the same, and you can do that, right? So, what are the websites? Data Hero, that is from datahero.com. Plotly, that is plot.ly. Number Picture, that is numberpicture.com. Polychart, Juice Analytics, Wave, Data Visual, Zoom Data, Row, Data Wrapper. You can say, ma'am, for few you have seen, you have said the websites, but after that you haven't seen. See, The links are there. You can put your mouse in that and you can get the websites. Fine. So you can say Juice Analytics, that is juiceanalytics.com, Wave, that is iwave.org, Data Visual, that is datavisu.al, Zoom Data, that is zoomdata.com, for Row, that is rowgraphs.io, and for Data Wrapper, it is datawrapper.de. Fine. So these are the online data visualization websites. Data visualization software. So for that, Table AU, SEP, Lumira, that is including a free personal edition version, Microsoft Excel, that is you can say, or any other spreadsheet that includes the charts, Clear Story, Mathematica, MATLAB, Matplotlib, which is available in the Python, R programming language, or ggplot2. Many can be there. I have listed only a few, right? So, people say that the 7 best data visualization tools available today. So, for this, today's best data visualization tools, we can list, say, Table AU, Quillic View, Fusion Charts, High Charts, Data Wrapper, Plotly, Sense, Google Charts. See, these are 7 best data visualization tool according to one particular website whose reference is given in the references. Many more can be there. That is only being followed from a particular website. That is, you can say that these are the typical tools people are using. It may be many more, right? See, I am not going to list out all the tools which are available. Fine. So some of them are being represented here, or the tools which are typically in use in the market today. Fine. Okay. So let us see about all this typical tools. So for that, we can say Table AU. What is that? We know that it is data visualization tool, right? So, but what is there in it? Table AU is often regarded as the grandmaster of data visualization software. Table AU has a very large customer base of 57,000 plus accounts across many industries. So, what do we say about them? And from where I got this figure? That is from Table AU tool website. They will be saying about that we are having these many accounts available for customers, right? So for the tools website, we can get this data. Due to its simplicity of use and ability to produce interactive visualization far beyond those provided by general business intelligence solutions. Business intelligence, that means providing intelligence to the business. And how do we provide the intelligence to the business? There are ways which we will learn in the subject of data mining. Fine. It is particularly well suited to handling the huge and very fast changing data sets which are used in big data operations, including artificial intelligence and machine learning applications. Quilic view. What is that? Quilic, with their Quilic view tool, is the other major player in this space and Table AU's biggest competitor. The vendor has over 40,000 customer accounts over 100 countries. What did we say about the Table AU? They have said they have 57,000 plus accounts. Here they are claiming that they have the 40,000 customer accounts. It is highly customizable setup and wide feature range are a key advantage. This, however, can mean that it takes more time to get to grasp it, right? So, should we use a software? Yes, we should, because it provides us highly customizable setup. In addition to, it offers powerful business intelligence, analytics, and enterprise reporting capabilities, and has clean and clutter-free user interface. Quilic View is commonly used alongside its sister package, Quilic Sense, which handles data exploration and discovery. There is also a strong community, and there are plenty of third party resources available online to help new users understand how to integrate with it in their projects. Fine. Next one is fusion charts. What is that? This is very widely used JavaScript based charting and visualization package in the paid for market. It can produce 90 different chart types. 90? Oh, we know only few. Bar chart, column chart, line chart, scatter plot, box plot, heat map, right? These things are known to us. But what it say? It can produce 90 different chart types. Ooh, that many names also are not known to us, isn't it? So we can know with fusion chart, right? With a large number of platforms and frameworks giving a great deal of flexibility. One feature that has helped make fusion charts very popular is that rather than having to start each new visualization from scratch, users can pick from a range of live example templates simply by plugging it in their own data sources as needed. So next one we want to learn is high charts. Like fusion charts, this also requires a license for commercial use, although it can be used freely as trial, non-commercial, or for personal use. Its website claims that it is used by 72 of the world's 100 largest companies. It is often chosen when a fast and flexible solution must be rolled out with a minimum need for specialist data visualization training before it can be put to work. A key to its success has been its focus on cross browser support, meaning anyone can view and run its interactive visualization, which is not always true with newer platforms. Next is data wrapper. Data wrapper is increasingly becoming a popular choice, particularly among media organizations, which frequently use it to create charts and present statistics. It has a simple, clear interface that makes it very easy to upload CSV data and create straightforward charts and also maps that can quickly be embedded into reports. Next one we want to know is Plotly. Plotly enables more complex and sophisticated visualizations. Its integration with analytics oriented programming languages such as Python, R, and MATLAB. It is built on top of the open source D3.js visualization libraries for JavaScript, but this commercial package adds layers of user friendliness and support as well as inbuilt support for APIs such as Salesforce. C-Sense, what is that? It provides a full stack analytics platform, but its visualization capabilities provide a simple to use drag and drop interface which allows charts and more complex graphics as well as interactive visualization to be created with minimum of hassle. It enables multiple sources of data to be generated into one easily accessed repositories where it can be queried to the dashboards instantaneously, even across big data size data sets, right? Dashboards can then be shared across organizations, ensuring even non technically minded staff can find the answers they need to their problems. Next one is Google Charts. Google Chart is one of the top trendsetters in big data. The company has designed Google Charts, a JavaScript charting library that enables web apps by incorporating interactive charting ability. So if you want to work with data visualization in future, you must thorough with Google Charts. You can build a variety of charts on Google Charts, including bar charts, area charts, line charts, pie charts, spline charts, etc. The chart options are numerous and you can personalize them to present your data in the best way. They range from simple to complex charts. In addition, charts made using this tool come in HTML5 and SVG formats. They can therefore be viewed on any device or browser. Now, next topic which we want to study is key factors of data visualization. In that, we want to learn control of presentation, faster and better JavaScript processing, rise of HTML5, lowering the implementation bar. Right? These are the major topics which we want to cover in the keys factors of data visualization. Before learning these topics in detail, we should know about the HTML5. So, what do we say about that? For HTML5, in our subject, data visualization. So, first of all, HTML started in 1989, HTML 2.0 in 1995, HTML 3.2 in 1997. In that only HTML 4.0 come. Then after XHTML 1.0 that came in 2000, and we can say XHTML, that is extended HTML, is 2.0, and then after came is HTML5, that was in 2004. So, what is the difference between HTML4 and HTML5? This we should know because we have studied the tags of HTML4. Fine. So, let us see the difference. So, after that, we can learn it properly. Fine. So, full duplex or streaming, the parameters I have given here, and then after we have given the comparison. You can have the table wherein you can say features are there, HTML4 and HTML5 is there. That way also you can do. Here in this format, that is with the feature, we are presenting the HTML4, HTML5, or you can say whatever is the difference. This is also one way, but feature wise comparison, right? That is the most important thing, right? Okay, so let us see the first feature, that is full duplex or streaming. For that, we can say in HTML4, communication between the client and server was done through streaming and long polling. Since there were no WebSockets available in HTML4. So what about HTML5? In HTML5, client and server communication support, it contains WebSockets that allow full duplex communication between clients and servers. Second feature, that we want to consider is malformed documents. HTML5 provides consistency in malformed documents handling, and that is, we can say, HTML5 handles better error handling than HTML4. Next is tags. HTML5 has more advanced tags like canvas, video, audio, etc. Multimedia tags. Multimedia is supported by HTML5, whereas HTML4 supported these things by third party like Silverlight and Flash. So first of all, we can say, how do we start the HTML5? That is, we can say, we have to write the doc type. That is, we can say document type. And there we can write this way, that is less than exclamation doc type HTML, then public, say dash 2 slashes W3C, again 2 slashes DTD HTML4.01 slash double EN system, and the DTD, that is document type definition, right? Or simply we can say, we can write it as less than exclamation doc type HTML, fine?